Hello.
Hi, everyone, and good afternoon. I hope you've all had an amazing conference so far, and I'm going to try not to keep you too long since I know we're right up against lunch. But I'm very excited to be here closing out the talks on a topic that you have all been waiting for, testing with JUnit 5. So before we get into the meat of the content, let me just really quickly introduce myself. My name is Justin Baumgartner, and I am a technical senior consultant at a Chicago-based digital innovation consulting firm called SOLSTICE. In the last 3 years I spent at SOLSTICE, I've worked on replatforming and modernizing a Fortune 1000 monolith into a microservice architecture. And I've also spent time with an array of front-end technologies such as iOS, Android, web, including architecting one of our Fortune 500 banking iOS apps. But enough about me. Let's jump into the agenda. So first, we're going to take a look at automated tests and how our testing needs have grown significantly over time. We're going to take a quick look at where we've been. We're going to take a look at through the lens of JUnit's tenure over the last decade since it was originally introduced. After that, we're going to spend a majority of the time talking through where Java unit testing is heading. Specifically, we're going to talk about some of the new features of JUnit 5, including their new architecture. And lastly, it would not be a Solstice demo without a Solstice talk without a digital experience demo. And in this demo, we're going to run through a really simple customer service Slack bot, and then we're going to take a look at the code and some of the corresponding tests. So it's all about the tests. Out of curiosity, how many developers here use JUnit 4 in their own projects? Quite a few. In case you're curious, I believe there's been several studies showing most commonly used like the Java dependencies, and by far and away, JUnit is always the most used dependency across GitHub and other projects. And it makes sense. But how many of the developers in the crowd here can remember the context in which you first created your first test? Most likely, in almost all of these cases, it was probably a unit test. For me, I was working on an established code base that was never in any way, shape, or form architected to support unit tests. And then one day, out of the blue, the client asked that we start writing unit tests alongside newly committed code. It did not take me but 10 minutes to realize that this was going to be very difficult, as retrofitting unit tests on an existing code base is not easy. But it was interesting to look back and realize how different our automated testing needs and expectations have become in just the 6 years since that code base was first established. So in fact, when it comes to software development today, one could argue that it really is all about the tests. And that's because we live in a TDD and CI/CD world where automated testing lies at the center of how we build modern software. This newer approach to building software is creating greater importance on tests than ever before. Our use of automated tests have grown in breadth and scale. We don't just support unit tests, we support integration tests, system tests, and UI tests. And finally, dev and build tools are competing for your business. And in those cases, these tools are also looking to push the capabilities forward. So to give you kind of an idea of how much has changed since JUnit 4 was first introduced, kind of walk you through a quick timeline of some major events that have happened since 2006 when JUnit 4 first came out. In 2007, the iPhone was released. 2008, the first GitHub repo. In 2013, Slack launched. And in 2014, Java 8 was released. So even though a majority of us here have used JUnit 4 in some sense, that's not to say that there aren't problems with JUnit 4. And I'd like to review some of those major issues right now. One is tight coupling. One of the major reasons that the JUnit team decided to rewrite JUnit 5 from the ground up is that the existing system tightly couples the test writing API with the test discovery and execution APIs. The test writing APIs being the APIs that us as developers typically interact with, and the test execution discovery APIs being the APIs that typically your build tools, your IDEs would be interacting with. Currently today, those all live under one package. So for one to move forward, everything has to move forward. I think Johannes Link, who is a core committer on JUnit 5, really summed it up nice when he said, "The success of JUnit as a platform prevents the development of JUnit as a tool." JUnit 4 is also being introduced 11 years ago, built on Java 5. And a lot has changed since Java 5. You can't take advantage of Lambda expressions or any of the exciting new language capabilities that have been introduced in the last few years. Finally, JUnit 4 is riddled with constraints and limitations, especially on extensibility. For those of you that I'm sure are familiar, the current extensibility platform is all on runners and rules, but both limitations. With runners, they're big, heavy objects, and you have to implement a lot to get some functionality. And you can only have one runner on your test cases. Rules were introduced later to try to alleviate having multiple rules on a test case. But the issue there is that they don't provide a whole lot of flexibility. As I'm sure you're aware, with me standing up here today, the light is shining through, and JUnit 5 is coming. So for those that aren't aware, Milestone 4 was released back in early April, I believe. Milestone 5 is actually coming out this upcoming Sunday, and the final stable release is scheduled for early fall. So let's hop into some of the major features. I would say that JUnit 5's most admirable feature is its new architecture. JUnit 5 decoupled their execution and writing APIs into separate packages. So you have the JUnit Platform. This is the API for build tools and IDEs to use to discover and execute tests. One of the really interesting things that I don't think we're going to know how it's going to play out yet is what the platform does is it exposes APIs for engines to be written to run on top of the JUnit platform. But that doesn't mean you're limited to just using JUnit tests. An engine could be built for TestNG or Spock or Cucumber or any other testing framework on top of the JUnit platform, meaning if the stars align, maybe we'll have a singular platform to run Java tests on. The second piece is JUnit Jupyter, which is the API for writing tests. Now, you might be wondering about the Jupyter name. Jupyter being the fifth planet from the sun. You got your name. And hopefully we'll be saying JUnit Saturn before 2028. Additionally, there's JUnit Vintage. JUnit Vintage is another test engine separate from JUnit Jupyter that can run JUnit 3 and JUnit 4 tests. And this is really important for this gaining traction because you can have a project with JUnit 3, JUnit 4, and JUnit 5 tests all living side by side. meaning there's no reason to not go home and add this as a dependency today. JUnit 5 is built on Java 8, meaning you get Lambda support. You're going to see a little bit more on what some of this looks like later in the demo, but you can see here they're using it for showing a message as a Lambda function, but there's also new assertions that take full advantage of Lambda functions. I think the other thing that you guys are really going to appreciate, and this probably affects you, I would argue, more than anything else that's changed, is their new extensibility model. So extensibility in JUnit 5 completely did away with runners and rules. Those are no longer a concept that JUnit 5 understands. Instead, they are calling these things extension models. And extension models expose certain extension points for developers to interact with. Now, some of these are going to look really familiar. You know, before all, before each, before test. Not anything earth-shattering, but you're going to see in the next couple slides some of the new extension points that really pushes the boundaries forward. So each of these extension points are just interfaces that you implement on top of some sort of extension model. In this case, it's the before each callback. And you implement before each, and you can do whatever you like in there. One thing that's really important to note is that these need to be stateless, because the JUnit 5 cannot guarantee when extensions are created and garbage collected. In each of the lifecycle methods or extension points, you are passed a extension context. And that extension context has a store on it, which is just a simple key value pair dictionary. So you can pass parameters across different life cycles of your tests. And if you're wondering an example of that, it'd be right here, the timing extension. And this would be an extension for if you wanted to print out how long it takes for a test method to execute, for example. Yes, yes. Correct. There's the before and after in this case. Before storing off in the store the start time, and the after grabbing off the end time, taking the difference and printing out to standard out what the time it took to execute that extension was. Implementing it is super easy. On your test cases, you just say extends with the timing extension. And with this, you're no longer limited to a single runner. You can have as many extensions as you like. You can also implement the extensions on methods themselves, so you don't have to actually implement it on the entire class if you don't want to. So if it's something that you just want to apply to a certain test method, you're free to do that as well. I mentioned some of the even more interesting things you can do with the new extension model, and I think this is my favorite. It gives you the ability to pass parameters into your test methods. So you can see in this example, you are extending with the mocked system extension. And in the test method, you're saying you can pass in a mocked system parameter, meaning you no longer have to put everything at the global scope, which can lead to defects with or issues with your test where you're carrying state across. And if only a single test really needs that parameter, you can keep it scoped to within that single test, because your extends with can be at the test method level. In terms of what one of these extensions look like, it implements the parameter resolver. interface. And you need to implement two methods. You implement supports, which tells you exactly what types or what annotations or whatnot do I accept as parameters. And then you implement resolve, which actually creates the instance of the parameter that you want to pass in. So a great example of this, which you'll see in the demo as well, is there's a Spring extension that I believe is going to be bundled with Spring Boot 2 and Spring 5, where you can inject in @mock MVCs into your parameters, so you no longer have to do like a mock MVC at the entire container level. Outside of just changes to extensibility, there's also a bunch of new tests. So there's dynamic tests. While most of the time your tests are going to be static or known at compile time, there are situations where you might want to dynamically create tests at runtime. And you can do that with dynamic tests. There's this @testFactory that you need to mark your test method with. And then your method itself needs to return an array of these dynamic tests instances. And in your IDE or your build tool, whatever you use, these will actually come out. It won't be like spit out as, oh, this is just a for loop of looping over these tests. This will spit out as individual tests within your IDE that get called out, so some can fail and some can pass. And for dynamic tests, they would need to return either a list or a stream or some sort of iterable thing. There's also parameterized tests, similar to dynamic tests. The difference being that for parameterized tests, the input is injected A as a parameter. It's also declared at the class level. In this scenario, it's simply just an array that we're passing in, but you can also load in external files, like you could load in a CSV file if you had something that was a little bit more complex. It's fully compatible with JUnit 4 and JUnit 3. So anything that you could do in JUnit 3 and JUnit 4, you could do with JUnit 5. I will give a caveat with that. The only thing, because runners and rules are no longer a thing on the JUnit platform, runners and rules no longer exist. They ported over some rules, but the expectation, and this is the one limitation to the JUnit platform, the expectation would be that you would, if you wanted to use the new JUnit Jupyter test engine, you need to port over any of your runners and rules that weren't one of the automatically ported over ones to the new extensibility model. So that is the one downside, but keep in mind that the vintage test engine does still exist, which should still be 100% compatible, backwards compatible with JUnit 3 and JUnit 4. Correct. It will run the tests as an input, in this case, the argument being 1, 2, and 3. And kind of similar here, there's also repeated tests, where if you, for some reason or another, wanted to run the same exact tests X number of times, and there's no dynamic input in this scenario, you can do that. So in this case, repeated tests is run 10 times in a row whenever you run the whole test suite. No, I mean, when you say that, do you mean the test container? Like no. Just like before, the test container itself wouldn't be a separate instance. So if you kept global state within that container, that could technically be shared across tests. They made some more annotations and technical changes with JUnit 5 as well. They introduced a disabled annotation, and you can disable either at the test method level or the test container level. This is kind of a cool one. They introduced display name. So no longer do you have any excuse to write this really confusing test that nobody knows what it does. So you can mark a test with a display name. including emoji support. So my understanding is that, for disabled tests, they appear in the report, but are classified as not run. Whereas if you use ignored, then they completely don't appear in the report. Is that your question?
Yeah. Also, like that reporting engine is case.
Yes, it should be. Yes. Tag, which replaces categories, and use that to group filter tests. It's my understanding there really isn't any major changes here. And there's some more that I didn't specifically draw out some slides for. So a lot of this is still in development as milestones are still coming out. There's nested tests. So if you follow more of a behavioral-driven testing style, you can nest test containers within test containers. Scenario tests, I think scenario tests look really cool. This isn't finalized yet, but it would be a set of test methods, and you mark test methods, which what is the next step in the scenario, and if that test passes, it goes to the next step, meaning you should see kind of a linear following of the test cases and knowing if a test fails, at what point in the process did it fail, even more easily than before. Dynamic containers, so just like there's a test factory where you can dynamically generate test cases, you'll also be able to dynamically generate test containers. And there'll be Java 9 compatibility. And all of this is scheduled to be done before early fall when JUnit 5 is released.
What's the current version 5?
They're on Milestone 4 right now. So you can go into your Gradle or Maven, and you should be able to add in Milestone 4. And keeping in mind that because they are separate packages, you need to pull in the platform itself, and then also whatever engine you want to opt into. So as I mentioned, we're going to do a really quick demo, super simple, a Slack bot, a little demo guy, just a quick run through of what it does and the architecture. I'm going to have a Slack client here on my machine. That's going to be hitting a Spring Boot application. Spring Boot application is utilizing a framework called JBot, which is really cool. It kind of it abstracts out all the annoying working with WebSockets and stuff, and it allows for really, really easy integration into a Slack bot APIs. It's going to take whatever text you passed in and pass it off to API AI to do the natural language processing and get back what action you're trying to perform. Depending on that action, if we recognize that as a reset password, which is currently what our bot understands, then we're going to ask you for a security question. If you get the security question wrong, we're going to reach out to a Giphy client and present a epic fail GIF. If you get it right, then we will generate you a new temporary password and send that back. Unlike the previous presenter, I do cheat, and you do not want to see me bumbling up here writing code. So everything is already written, and I'm just going to kind of walk you through some stuff. So let's start simple. Customer model, just a simple model, nothing fancy here. Let's take a look at some of the tests for that. So the customer class, here's a customer test. You can see we have the @test and @display_name. So if I run these tests, it will show up under the build tool as password persistence test and not new password should persist. You can see here I'm using the assert equals. I'm using the new Lambda functionality. I believe assert all is a relatively new assertion. where you can pass in a Lambda and have a group of assertions that are all going to be grouped together. The IDE, obviously, it'll depend on your build tool, but in this case, IntelliJ, it will still separate these out as separate asserts, but if there is a failure, it's kind of like a hierarchical view where you can see that these guys are all grouped together. You also note that we wrote a customer resolver extension, which allows for passing in a customer into this test method. So if I hop into this, you can see that, as I talked about before, it implements the parameter resolver interface. And it has supports, and it says I support passing in a customer class. And it generates a customer object that's just static, nothing too fancy here. Let's also look at a customer controller. Customer controller is a simple REST controller that, if you hit, would print out the database and the entities that are in the database. You can see here we're using multiple extensions. So using the Mockito extension. We're also using the Spring extension. The Spring extension allows for passing in an auto-wired mock MVC, which is very cool. So we no longer need to declare these at the class level. And then we're also down here, not that you would probably really do this, but using a plain old @mock from the Mockito extension. And the customer service, this is the kind of the guy that does all the heavy lifting, takes in the message that you typed into the Slack bot and the customer ID, and it calls out to API, and it calls out to Giphy, and it responds back to you with what I want you to say. And the test here is an example of using Test Factory. So you can see here, here's some phrases that I currently support. And I want to assert that the bot says, yeah, I can help with that. Just like before, there's still before tests and after tests. The wording of these annotations has changed slightly, but there is before each, which will execute before each individual test case, and there's before, which will execute when the container is initially instantiated. As an example, here's a JUnit 4, kind of a mixed rule. So you can see this is at test. It's using the JUnit 4 legacy imports, but we're also importing the new JUnit Jupyter imports. So notice that there isn't any package conflicts or anything like that. It's its own separate entity now. And within this JUnit class, we're using old style tests and the new JUnit 5 tests. And one last one I'll point out really quick is parameterized tests. So you can see here, this class is generating a new password, which is just a random string. And I want to assert that for all different expected lengths, that it does actually assert that this is the correct length. That I can't speak to because I am not old enough. I do not know what the JUnit 3 to JUnit 4 migration path looked like. Yeah, I'm not sure.
Is the new migration path that you just use the Jupyter imports and your code works as is?
Well, keep them, yeah, because the new, exactly. And with the new one, if you're using the vintage test engine, I mean, theoretically, there's really no upgrade path because it can run old tests. You can see here that all the tests did pass. And notice here, so this is, I believe this was the, this is the dynamic test. So you can see that it grouped them together as like, hey, this is a should process reset password message, but it still separated out each of those test instances. So if one of these failed, it's going to call out as this one was a failure. I also want to look at under customer test. Here's where we're using the new display names. So notice here it does not say new password should persist. It says the display name of password persistence test. And just same thing here, a security question persistence test. So then the very last thing before I let you guys go eat is let's make sure this demo actually works. So run this guy. So customer service or customer support rep is online, and let's ask him to reset our password. So I'm going to ask, can you reset my password? He's going to reach out to API AI, find out what intent I was trying to say, realize I was trying to reset my password, and then ask a security question. In this case, asking, which city do you believe the world's best Spring developers reside? I am an idiot, so I'm going to write San Francisco. And, oh, it's so sad. The GIF came but did not display because I don't have my settings set up correctly in Slack. It's so sad. But you can see the failure GIF there. So let's try that again with the, oh, there it is, with the correct answer. And this time we're going to answer correctly and say New York. And success, I got a new password, and I can go on about my day and log in with my new temporary password. Any other questions? I'm not sure what they're planning to support, to be honest, because it's not done yet. It's set for Milestone 6, I want to say, that for any, I guess, potentially new language features they might try to support. But I don't know because it's not done yet. So.
Java 9 gets delayed yet again. Is that going to affect the release?
I highly doubt it. My assumption would be that they're going to ship in early fall no matter what. They already have Milestone set up for like a backlog and stuff, so my assumption would be that they're just going to push off anything to the backlog. But I don't think they've specifically said that yet. So. Cool. Thanks, guys. Enjoy lunch.